When we're simplifying radicals that have fractions in them, what we're going to do is we are going to follow the same procedures that you would if there weren't fractions, but we're going to do it twice. So when we start here with our first example of the square root of 9 over the square root of 50, you are going to rewrite that as the square root of 9 over square root of 50. And then you're going to simplify each one of those terms. So we know right away the square root of 9 is 3. All right, now the square root of 50. Well, we know that we're going to have 25 and 2 and 5 and 5. So we're going to put this 5 on the outside of our radical and the square root of 2 on the inside. Now, the thing with this is you can't stop here. You cannot have a radical sign in your denominator. So we need to do something called rationalizing the denominator. We're going to multiply both the numerator and the denominator by 1, but we're going to manipulate what 1 looks like in order to get rid of that radical sign. So in order to get rid of this square root of 2, we're going to multiply both the numerator and the denominator by the square root of 2. Now, would you agree that the square root of 2 over the square root of 2 equals 1? Yes, that is 1. And anything we multiply by 1 is just going to equal what we got or what we started with. So what we're doing is we're just manipulating the rule there and changing what 1 looks like in order to get rid of this radical sign. So that's going to leave us with 3 square root 2 all over 5 times square root 2 times square root 2 is 2. So that's going to give us 3 square root 2 over 10. That's going to be your simplified version of the square root of 9 over 50. Okay, again, this is something that once you have simplifying radicals without fractions down, this is just doing the same thing twice, just on the numerator and the denominator. So let's do the square root of 50 over 8. We're going to rewrite it as the square root of 50 over the square root of 8. All right, and we're going to do the prime factorization of each one of those numbers. So 50 we just did before over here, we know is going to be 25 and 2, which is going to give us 5, 5 and 2. And 8 is going to be 4 and 2, which is going to give us 2 and 2 and 2. All right, so let's circle our pairs that we have here. And let's rewrite our expression. So we're going to put this 5 on the outside for our numerator, and we still have a square root of 2 left. And in our denominator, we're going to put a 2 on the outside, but we still have a square root of 2 left. Now we need to, well, there's two different things that we can do in this situation. One, the square root of 2 over the square root of 2, we know that that's going to be 1, so we could just cancel them out. But we're going to multiply both sides by the square root of 2, square root of 2, and that's going to give us 5 times 2 all over 2 times 2, which is 4. Oops, I wrote that as the 10 already. I did the math. Sorry about that. It happens, right? Let's see if I can erase. I can. That's going to give us our 10 over 4, which is still going to bring us back to that 5 over 2. So your answer is going to be 5 over 2 for the square root of 50 over 8. Now let's look at a few examples that have some variables in them because inevitably we're going to be dealing with those, right? So the same thing, we're going to rewrite this. Square root of 4 over the square root of 49 e to the 6th. All right, so we know what the square root of 4 is. We know the square root of 4 is 2. And when we do the prime factorization of the square root of 49d6, we're going to find out that it's going to be 7d to the 3rd. And that's it. That's your answer. This one was a pretty simple one. Here's a little bit more complex one that you are going to run into as well. So again, let's rewrite it. We'll change colors because this one might get a little long. All right, so the square root of 5x to the 8th over the square root of 28. Well, square root of 5 that's already prime, so we know that that's going to stay in there. So we're going to have the square root of 5, x to the 8th, the square root of that, we're going to be able to figure out is x to the 4th, so that's going to go on our outside. The square root of 28, well, let's do some prime factorization here, and we're going to have 2 and 19? Not 19, my goodness, I'm with it, I promise, guys. 2 and 14. And then we'll do another 2 and 7. So we are going to have a pair here that's going to go on the outside, square root 7. Now, we can't leave it like that because we have this radical sign right here in the denominator, and we can't have that. So now we're going to take this x to the 4th, square root 5. I'm just going to rewrite it down here. All over 2 square root 7. And I need to get rid of this right here. So I'm going to multiply both the numerator and the denominator by the square root of 7. And that's going to give me x to the 4th times the square root of 35 all over 2 times 7, which is going to be 14. So x to the 4th square root of 35 all over 14. That looks a lot different from what we began with. Or what we started with, I apologize. So, but we have to remember that we need to be able to take those steps. Now again, just splitting them both up and doing or simplifying the problem on the numerator and then simplifying the problem on the denominator is going to be helpful. The thing that you need to remember is that if you have a radical sign anywhere in the denominator, you need to multiply by 1. 1 can look very, very different. Square root of 7 over square root of 7 is what we did here in order to get rid of that radical sign down in the bottom or in the denominator. Same thing here, our 1 looked different, square root of 2 over square root of 2. Same thing here, square root of 2 over square root of 2. So you just need to be able to manipulate what 1 is going to look like. I will post a couple of more videos if you need help. As always, if you have questions, reach out through Google Classroom, Remind, or shoot me an email. You guys are going to do great on this.